In this video, we're going to discuss the greatest common factor and how to factor by grouping. We will use the information that we learn in this video throughout the rest of the chapter. Let's start with the definition of the greatest common factor, also known as the GCF. The greatest common factor of a given polynomial is the largest number or variable expression that multiplies evenly into all terms of the polynomial. Let's look at some examples. To start, we want to find the greatest common factor of the numbers 8 and 20. In other words, we want to know what's the largest number that multiplies evenly into both 8 and 20. You might be able to just solve this mentally, but if you're having any trouble determining the GCF, I recommend you list the factors of the smallest number. So the smallest number between 8 and 20 is 8. So let's list all of the factors of 8. In other words, let's list all of the numbers that multiply to give us 8. 1 times 8 gives us 8, and 2 times 4 gives us 8. Now we want to find the greatest common factor between 8 and 20. These are the factors of 8. So we want to look at these factors of 8 and find what is the largest number here that is also a factor of 20. In other words, what's the largest number here that also multiplies into 20? And that would be 4. So the greatest common factor between 8 and 20 is 4, because 4 is the largest number that multiplies evenly into both 8 and 20. For example B, we want to find the greatest common factor between 16x and 40. If you're having any trouble solving this mentally, I would pick the smallest number here. So between 16 and 40, 16 is the smallest number, and let's list all of the factors of 16. 1 times 16 gives us 16, 2 times 8 gives us 16, and 4 times 4 gives us 16. So these are all of the factors of 16. Now we want to find the greatest common factor between 16 and 40. So what's the largest of these numbers that also multiplies into 40? 8 is the largest number that multiplies into both 16 and 40. So let's start by saying that our GCF is 8. Now notice here that we have an x here. So x multiplies into 16x, but since there's no x attached to the 40, that means that x wouldn't multiply evenly into 40. So we do not want to put an x in our GCF. So the greatest common factor between 16x and 40 would be 8. For example C, we want to find the greatest common factor between these three terms. Let's start by just looking at the coefficients, the 12, the 45, and the 24. We want to pick the smallest coefficient, which would be 12, and let's list all of the factors of 12. Here are all of the numbers that multiply to give us 12. Now, what is the largest of these numbers that also multiplies evenly into 45 and 24? That would be 3. 3 multiplies evenly into 12. 3 also multiplies evenly into 45 because 3 times 15 gives us 45. And 3 also multiplies evenly into 24 because 3 times 8 gives us 24. So for our GCF, we'll start with 3. Now notice all of these terms have a z. So if all of your terms have a z, you must put a z in your GCF. And to determine what z to put in your GCF, do you put z cubed, z squared, or z? When you're identifying the GCF, you always pick the variable with the lowest exponent. So between z cubed, z squared, and z is the variable with the lowest exponent. So that's what we put in our GCF. Because z multiplies evenly into all three of these terms. Z multiplies evenly into z cubed, z also multiplies evenly into z squared, and z multiplies into z. So our GCF for this problem is 3z. To find the GCF for example D, let's start by looking at the coefficients, 6, 14, and 10. And let's pick the smallest coefficient, which is 6. And let's list the factors of 6. Now we want the greatest common factor. So what's the largest of these numbers that also multiplies into 14 and 10? That will be 2. So when we're writing our GCF, we'll start with 2. Then let's look at the variables. Notice that all three of these terms have an x, so that means we have to put an x in our GCF. To determine which x to put in our GCF, we always pick the x with the smallest exponent. So between x to the fourth, x cubed, and x squared has the smallest exponent. So that's what we put in our GCF. Then notice that each term has a y. So that means that we need to put a y in our GCF. To determine what y to put in our GCF, we always select the y with the lowest exponent. So between y to the fifth, y cubed, and y to the fourth, y cubed has the lowest exponent. So that's what we put in our GCF. So the greatest common factor of these three terms is 2x squared y cubed. Now we're going to use the greatest common factor to factor some polynomials. In the examples below, you will be asked to factor a polynomial. Step 1, we will need to find the greatest common factor of all of the terms. Step 2, we will use the distributive property to factor out the GCF. And step 3 is an optional step where we can use the distributive property to check our work. So for these examples here, we're asked to factor out the greatest common factor. We're going to follow these three steps. Step 1, we need to find the GCF. I recommend that you start by looking at the coefficients 18 and 42. And let's pick the smaller coefficient, 18. And let's list all of the factors of 18. Now we need to identify the largest of these numbers that also multiplies into 42. That would be 6. 6 multiplies evenly into 42 because 6 times 7 gives us 42. So for our GCF, we can start with the number 6. Then we notice that both terms have an x. So that means that we have to put an x in our GCF, and we always pick the x with the smallest exponent. Between x to the fifth and x cubed has the smallest exponent. So we'll put x cubed in our greatest common factor. Step 2. We use the distributive property to factor out the GCF. So we're going to put the GCF outside of parentheses, and then since our original expression had two terms, we're going to put two spaces inside of our parentheses. Then we want to imagine if we were to distribute, what would we have to multiply 6x cubed by to get 18x to the fifth? Well, let's see, 6 times 3 will give us 18, and x cubed times x squared will give us x to the fifth. Remember, when you multiply x cubed times x squared, you add the exponents. So 3 plus 2 gives us our 5. So if we were to distribute, 6x cubed times 3x squared would give us 18x to the fifth. Next, we want to think, if we were to distribute the 6x cubed here, what would we have to multiply 6x cubed by to get negative 42x cubed? Well, let's see. 6 times negative 7 will give us our negative 42, and since we already have x cubed, we don't have to multiply by any variable to get x cubed. So this is considered factored form. You factored out our GCF. If you'd like to check your work, you just need to go ahead and distribute the 6x cubed to each of these terms and make sure that you get back to the original expression. So I've just recopied this exact expression here to show our final answer. Let's take a look at another example. We're again asked to factor out the greatest common factor. Step 1, we want to find the greatest common factor of these three terms. To start, let's look at the coefficients 35, 84, and negative 49. And let's pick the smallest coefficient, which is 35. And let's list all of the numbers that multiply to give us 35. Now, what is the largest of these numbers that also multiplies evenly into 84 and 49? That would be 7, because 7 times 12 gives us 84, and 7 times 7 gives us 49. So to start writing our GCF, we'll write 7. Now, notice that all three terms have an a, so that means we have to put an a in our GCF. And to determine what a we put in our GCF, we always pick the a with the smallest exponent, so that would be a squared. Next, notice that all three terms have a b. That means we have to put a b in our GCF. If all three terms did not have a b, then we would not put b in our GCF. Now, to decide what b to put in our GCF, we pick the b with the smallest exponent, which would just be b. Now we've identified our GCF, so now we want to factor out the GCF. So we start by writing the greatest common factor, 7a squared b, and then we draw our parentheses. Since the original expression had 1, 2, 3 terms, that means we need to put 3 terms inside of our parentheses. Now we need to imagine, what do we need to put in these 3 spaces so that when we distribute the 7a squared b, we get our original problem? Let's start with what would we need to multiply 7a squared b by to get 35a to the 6th b to the 4th? Let's take this piece by piece. 7 times 5 would give us 35. We'd need to multiply a squared times a to the 4th to get a to the 6th, because when we add these exponents, 2 plus 4, that gives us 6. Then we'd need to multiply b by b cubed in order to get b to the 4th. Because again, when we multiply b times b cubed, we add the exponents, and this implied exponent 1 plus 3 gives us 4. Next, we need to ask ourselves, what would we need to multiply 7a squared b by in order to get 84a cubed b cubed? Well, let's see. 7 times a positive 12 will give us a positive 84. A squared times a would give us a cubed. And b times b squared would give us b cubed, because the exponent here, 1 plus 2, would give us 3. Last, we need to ask ourselves, what would we need to multiply 7a squared b by in order to get negative 49a squared b? Let's see. 7 times negative 7 will give us our negative 49, and we have a squared b, and we want a squared b, so we don't need to add any variables here. So this is our final answer. I'm going to just copy down this exact statement right here. And again, you can always check your work by distributing. If you distribute the 7a squared b to each of these terms, your result should be the original problem. Now, when mathematicians were developing the language of mathematics, they had to create a set of rules for us to follow so that when we see a problem like this, we all come up with the same answer. One of the rules that mathematicians decided upon when factoring is that when the coefficient of the term with the highest exponent is negative, and in this particular example, our variables are p to the 4th, p cubed, and p squared. P to the 4th has the highest exponent. If the coefficient of the term with the highest exponent is negative, the greatest common factor is always negative. So if you notice that the coefficient of your variable with the highest exponent is negative, you know that your GCF must also be negative. And if your original problem is written in standard form, the term with the highest exponent will always be written first. So to factor this, we're going to use the same steps that we used on the previous page. Step 1, we need to identify the GCF. So let's start by looking at the coefficients here, and we want to ask ourselves, what is the largest number that multiplies evenly into 5, 10, and 25? That would be 5. But since the coefficient of the term with the highest exponent is negative, that means our GCF must be negative. Now, I also notice that each term here has a p, so that means we have to put a p in our GCF. And for the greatest common factor, we always pick the variable with the lowest exponent, so that would be p squared. Now for step 2, we're going to factor out the GCF. So I've started by writing the GCF, then we're going to draw our parentheses, and since our original problem had 3 terms, we'll put 3 spaces inside the parentheses. Now we want to ask ourselves, if we were to distribute, what do we have to multiply negative 5p squared by to get negative 5p to the 4th? We'd need to multiply p squared by p squared in order to get p to the 4th, because when you add these exponents, 2 plus 2, you get 4. Next, what do we need to multiply negative 5p squared by to get 10p cubed? Let's see, negative 5 times a negative 2 would give us our positive 10, and p squared times p would give us our p cubed. And finally, what do we need to multiply negative 5p squared by to get negative 25p squared? Well, let's see, negative 5 times a positive 5 will give us our negative 25. And we have p squared and we want p squared, so we don't need to add any variable here. So I've just copied down this exact expression here as our final answer. Next, we're going to look at a type of problem that's going to be helpful on the next page when we factor by grouping. Before we work through this problem, I want to look at a similar problem. This problem here is almost identical to this given problem. The only difference is that I've replaced the x minus 2 with z here, and I've replaced the x minus 2 with z here. Now let's factor out the greatest common factor. Step 1, let's identify the greatest common factor. If we start by looking at the coefficients 6 and 5, there is no number other than 1 that multiplies evenly into both 6 and 5. So we're not going to put any number in our GCF. Now, we notice that this term has an x, but this term does not. So since both terms do not have an x, we do not put an x in our GCF. Next, we notice that both terms have a z, so that means we're going to put a z in our GCF. Next, we want to factor out the GCF. So we start by putting the GCF outside of parentheses. And since our original problem has two terms, we'll leave two spaces inside of our parentheses. Now we want to ask ourselves, if we were to distribute, what do we have to multiply z by to get 6xz? Well, z times 6x would give us 6xz. Next, we want to ask ourselves, what would we have to multiply z by to get 5z? Well, z times a positive 5 would give us a positive 5z. So we've successfully factored this problem here. And again, I've just rewritten the final solution right here. Now that we've solved a similar related problem, let's now solve the original problem, which I've copied right here. Again, notice that the original problem is almost identical to the similar problem. The only difference is that we have x minus 2 instead of z. So for step 1, we need to identify the GCF. Just like the GCF here was z, the GCF here would be x minus 2. Step 2, we're going to factor out the greatest common factor. So we start by writing the greatest common factor here, and then we'll draw our parentheses. And since the original problem had 1, 2 terms, we're going to draw two spaces inside of our parentheses. Now we want to ask ourselves, what would we have to multiply x minus 2 by to get 6x times x minus 2? Well, x minus 2 times 6x would give us 6x times x minus 2. Then we need to ask ourselves, what would we need to multiply x minus 2 by to get a positive 5 times x minus 2? Well, x minus 2 times a positive 5 would give us a positive 5 times x minus 2. So we've successfully factored out our GCF. And again, I've just copied our exact answer right here to show our final answer. Notice these final answers are identical. The only difference is that here we have a z, and here instead of a z, we have x minus 2. Next, we're going to learn how to factor by grouping. Factoring by grouping is a strategy that is used to factor polynomials that have 4 terms. So notice this polynomial has 1, 2, 3, 4 terms. So we're going to factor by grouping. Same thing here. This polynomial has 1, 2, 3, 4 terms, so we're going to factor by grouping. Now you will hear me say this over and over again throughout this chapter. If the instructions say to factor, the first step is always to check for a GCF. So let's check for a GCF. To start, let's look at the coefficients. The coefficient of this x squared term is a 1, so we have a coefficient of 1, 7, 3, and 21. There are no numbers other than 1 that multiply evenly into all 4 of these coefficients. Also notice that all terms do not have a variable. We do not see an x in this term here. So since all terms do not have an x, we cannot put an x in our GCF. So here's an example of a problem that does not have a GCF. So once you check for a GCF, now we want to proceed to factor by grouping. When you factor by grouping, you're going to start by imagining that this were two separate problems. The first 2 terms will be one problem, and the last 2 terms will be another problem. So to start the process of factoring by grouping, I'm going to completely cover up the last 2 terms so that we can focus all of our attention on these first 2 terms. And we want to ask ourselves, what is the greatest common factor of these 2 terms? Since both terms have an x, for our GCF, we're going to pick the x with the smallest exponent, which between x squared and x, that would be x. So our GCF here would be x. Next, we're going to factor out the GCF. So I'm going to put the x on the outside of the parentheses, and then we can imagine if we were to distribute, what would we have to multiply x by to get x squared? Well, x times x would give us x squared, And then what would we have to multiply x by to get a positive 7x? Well, x times a positive 7 would give us a positive 7x. So now we've factored these first two terms right here. Now I'm going to cover up this part of the problem so that we can focus all of our attention on the second two terms. And just like we did with the first two terms, with the second two terms, we want to factor out the greatest common factor. So to find the greatest common factor, the largest number that multiplies into both 3 and 21 would be 3. Then notice that both terms do not have an x, so we do not put an x in our GCF. Now that we've identified the GCF, we want to factor out the GCF. So our GCF is a 3, and I'm going to write plus 3 to connect this answer to our previous answer. If the GCF here was a negative 3, then I would write minus 3. Then we'll draw our parentheses. And let's imagine if we were to distribute 3 times x would give us 3x, and 3 times a positive 7 would give us our positive 21. So we've successfully factored out the GCF of these two terms. Now we want to look at the problem as a whole, and we want to factor this given expression. Notice that this expression here is very similar to the expression from problem 4. So we're going to use the same approach that we used in problem 4. And I'm going to show you the logical way to factor this, and then I'll show you a shortcut that most people prefer. So if we look at this expression as a whole, we need to identify the greatest common factor. The largest expression that multiplies into both of these terms is the quantity x plus 7. So our GCF is the quantity x plus 7. Now that we've identified our GCF, now we're going to draw our parentheses. And we want to imagine if we were to distribute, what do we have to multiply x plus 7 by to get x times x plus 7? Well, x plus 7 times x would give us x times x plus 7. Then we want to ask ourselves, what would we have to multiply x plus 7 by to get a positive 3 times x plus 7? Well, x plus 7 times a positive 3 would give us a positive 3 times x plus 7. Now that's the logical way to think through this, but most people just use a shortcut to get to this step. And the shortcut says, once you reach this step, to get to your final answer, you just find the matching factor, which is x plus 7, and you start by writing that. And you write that factor only once, even though it appears twice here. Then, what you put inside these parentheses just comes from these outliers here. So we put an x here and a positive 3 here. We'll practice this shortcut on the next problem. So I've copied this down for our final answer right here. Please know that for your final answer, the order that you list these factors does not matter. So if instead for your final answer you put the x plus 3 first and the x plus 7 second, this would be correct as well. Let's take a look at one more factoring by grouping problem. Now remember, in any factoring problem, the first step is always to look at your original given problem and see if there is a GCF of that original given problem. So to find the greatest common factor of this original given problem, we need to find the largest expression that multiplies evenly into all 4 terms. To start, notice that this first term here, the term that has the variable with the largest exponent, has a negative coefficient. That means that our GCF must be negative. So I'm going to start by writing a negative here so that I don't forget. Next, what's the largest number that multiplies evenly into 2, 6, 10, and 30? That would be 2. So we'll add a 2 to our GCF. Then we notice that all 4 terms have a W, so that means that we need to put a W in our GCF. And when we're determining the GCF, we need to pick the W with the lowest exponent. That would be just W. So now we've identified our GCF. Next step is we need to factor the GCF out of this expression. To do that, we start by writing the GCF on the outside of parentheses here. If you forget to factor this GCF out in the first step, you'll end up with the wrong answer at the end. Now, since we see 4 terms in the original problem, we'll have 4 terms inside these parentheses. First, we need to ask ourselves, what do we need to multiply negative 2w by to get negative 2w to the 4th? Negative 2w times w cubed will give us negative 2w to the 4th, Because remember, when you multiply w times w cubed, you add the exponents, and the exponent 1 plus 3 gives us 4. Next, we ask ourselves, what do we need to multiply negative 2w by to get a positive 6w cubed? Well, let's see. Negative 2 times a negative 3 will give us a positive 6, and w times w squared will give us w cubed. Next, what do we need to multiply negative 2w by to get a positive 10w squared? Well, negative 2 times a negative 5 will give us a positive 10, and w times w will give us w squared. Finally, negative 2w times a positive 15 will give us negative 30w. Now that we've factored out the GCF, now we can move on to the grouping part. We're going to group these first two terms together, and we're going to group these last two terms together. Now we need to make sure to include the GCF in our final answer. But for now, we can ignore the GCF until the very end. In fact, I'm going to block out the GCF and the last two terms so that we can focus on these first two terms here. We want to factor these two terms, and so we need to ask ourselves, what is the greatest common factor of these two terms? That would be w squared. So to factor these two terms, we put a w squared outside of parentheses, then we draw our parentheses. Then we ask ourselves, w squared times what gives us w cubed? W squared times w gives us w cubed, and w squared times a negative 3 will give us our negative 3w squared. So we've successfully factored the GCF out of these first two terms here. Now I'm going to block out the first half of the problem so we can focus on these last two terms here. Again, we want to factor the GCF out of these last two terms. Notice the first term here is negative. In other words, the term that contains the variable with the highest exponent has a negative coefficient. So mathematicians have agreed that when that's the case, your GCF must be negative. So we know we'll have a negative GCF here, and the largest number that multiplies into both negative 5w and 15 would be 5. And since our GCF needs to be negative, we'll write negative 5. Next, we'll draw our parentheses, and negative 5 times w will give us our negative 5w, and negative 5 times a negative 3 will give us our positive 15. So we've successfully factored the GCF out of these two terms here. Now let's look at the problem as a whole. Again, I'm just going to ignore this original GCF for the time being. At this point, you'll know you're on the right track if you have two matching quantities here. If these quantities don't match, you'll want to go back and check your work. Now let's use the shortcut to write our final answer. For our final answer, you take this matching term, w minus 3, and write it once here. Then, to figure out what to put in this second set of parentheses, you just look at these outliers. We write w squared, and then minus 5. Then the number one most common mistake for these types of problems is to forget to put the original GCF in your final answer. You always need to include the original GCF in your final answer. Always double check your work because that's the most common thing that we forget. So I'm going to bring down the negative 2w for our final answer. And this right here is the final answer that we get when we factor by grouping. Now remember, the order that you list these factors doesn't matter, so we could have instead written our final answer like this.